are now prepared to investigate functions and equations a little bit further, so we're going to add a couple vocabulary words today. So in 512, the I can statement is I can identify linear, which we've talked about before, linear and nonlinear, and increasing, and you can probably guess what the other word would be here, decreasing. Okay, so we're going to be talking about linear and nonlinear, increasing and decreasing. So these, as you can kind of tell from the vocabulary, these are kind of opposites of each other. Linear, nonlinear, increasing and decreasing. So when we talk about the word linear, we've talked about that many times before. Think about the root word here. What does the word linear mean? It means a line. Okay, what does increasing mean? We could describe this a bunch of different ways. We could say gets bigger. Okay, if something is increasing, it gets bigger. The value of it goes up or something like that. So if it's decreasing, that would be just the opposite. It gets smaller. Okay, or goes down. The value of it goes down. Okay, now if you had to guess which of the following graphs come from linear functions, which one would you say come from linear functions? Well, it turns out looking at a graph and telling whether or not it's linear or not is pretty easy because the root word says line, so this one is linear. Okay, this one right here, you'll notice it's got a bit of a curve to it. It is not a straight line, so we're going to say that this is non-linear. Okay, that's the way we describe that, non-linear. This one is also kind of curvy, so this one would be non-linear. And I've seen this both ways. You can see it with a hyphen and without a hyphen, so either way is fine with me. And then this last one, this is also a straight line, so this would be linear. Okay, so looking at a graph and figuring out whether or not it comes from a linear function or not, that's pretty easy. If it makes a single straight line, okay, then it's linear. But if we have to look at an equation and tell whether or not it's linear, that is a little bit more difficult, but not too much more difficult. Okay, so we're going to deal with a bunch of linear equations in math, so it's really important to tell whether or not we're dealing with one to be able to recognize them quickly. So linear equations come in lots of different forms that look very different. You can have a linear equation that, depending on the format, you might go, oh, that looks familiar, that's in slope-intercept form, I know that's a line. Or we can mess with it a bunch and make it look really weird, and then you might go, oh, I don't know about that. But they do all have some key features in common. So here's what we can say about linear equations. Linear equations can have coefficients, okay, so they can have numbers in front of the variables. They can have constants, and they can have a plain old x, a plain old y, or both. Okay, so when we're looking at linear equations, they've got a plain old x, a plain old y. They might have coefficients in front. There might be constants in the equation. But they don't have anything like this once we've simplified them. They don't have any exponents. They don't have any squares or square roots or cubes or cube roots or anything like that. And there's never an xy term where the x's and y's are multiplied together. There aren't any variables in the denominator, so we're not going to see any fraction bars with variables in the denominator. Not that you never see fractions, but you're never going to see a fraction with a variable in the denominator. In other words, we don't have any weird stuff. Okay, there's nothing crazy going on. So if you're looking at an equation, all you're looking for is plain old numbers, plain old x's, plain old y's. It's okay if there are both, but there's nothing weird like exponents, roots, or anything like that. So let's take a look at this one right here. It says determine whether each equation is linear or nonlinear. And remember, nonlinear means not a line. That's what nonlinear means. So if we take a look at this one right here, what we're looking for is, do we have a plain old x? There's nothing weird with it. There are no square roots of x, no x squared or anything weird like that. And it's totally okay to have a coefficient there. So we've got this plain old x term with a coefficient, plain old y term with a coefficient, and then this over here is a constant. So this is linear. Okay, so we've got that one. If we take a look at this one, this is the exact same problem. We've got the 12, we've got the equals, we've got the 4y, we've got an x, but this time instead of the 3 being a coefficient out in front and being multiplied with the x, we're taking x and we're cubing it. We're raising it to the third power. So this is not a plain old x, it's an x cubed, so this is non-linear. Okay? And it's really that simple. Let's take a look at the problems we've got here. We've got an x squared, we've got an x raised to the second power. That's not okay. And we have a y in the denominator. That's not okay. So this is non-linear. All right, take a look at this one right here. Plain old y, coefficient in front would be a 1. This is an x with a coefficient here. We do have a fraction on this one, but you'll notice there's no variable in the denominator. So fraction coefficients are totally okay, as is this constant. So that one would be linear. The next one, plain old y, but on this side we have a square root of x. That makes it non-linear automatically, okay? And then the last one is x equals 4. So on x equals 4, remember we've got a plain old x. We've got a constant in there. There's no y. That's totally okay. This is linear. And if you remember what this looks like, x equals 4 is a vertical line right here. So that is definitely a linear equation. Okay? All right. Now, in addition to being able to tell whether or not we've got a function that's a linear function, we also want to be able to tell whether or not it's increasing or decreasing. And the easiest way to do this is by looking at a graph and kind of keeping track of, well, what does increasing mean? Remember, increasing means it's getting bigger or going up, and decreasing means it's getting smaller or going down. Now, we usually do this from left to right, so kind of as we read. So as the x's are getting bigger, so notice we start out at -4, then -3, then -2, then -1, and so forth. As we're going from left to right, notice that the y values here would start out a little below the x-axis. They'd hit 0 and then go above. So the y values are getting bigger. This is increasing. Okay? This one right here, as we go from left to right, so as we go from the negative side of the x-axis to the positive side of the x-axis, notice that the y values are getting bigger. They're going up like this. So this one is also increasing. Now, if we take each one of these examples and kind of flip them around just a little bit, as we go from left to right, these y values are getting smaller. They're going down. So this one is decreasing. And same thing on this one, as we're going from left to right. So as we go from the left side of the line to the right side of the line, they're getting smaller. So this one is also decreasing. So we can describe this really easily. So if it's increasing, that means the graph goes up from left to right. So these are increasing examples right here. And it means the graph goes down from left to right if it's decreasing. So here are decreasing examples. Notice that they're going down. Now, another way that we can describe this is as x gets bigger. So as the x's get bigger from left to right, y gets, if we're increasing, y gets bigger. So they're both getting bigger. And as x gets bigger, y gets smaller if it's decreasing. Okay? So again, smaller goes with decreasing, bigger goes with increasing. And we'll flip this over to the other side. And the reason we want to have that other explanation or that other description of what increasing and decreasing is, sometimes you're just given a table, and rather than plotting these points and graphing them and stuff like that, it's just easier to look at this and say, okay, what's happening with the x here? So it says determining which tables are increasing and which are decreasing. So if we look at the x's right here, notice that the x's are getting bigger. They're getting bigger by 3 every single time. And look what's happening with the y's. Getting smaller, getting smaller, getting smaller, getting smaller. So this would be decreasing, because as the x's are getting bigger, the y's are getting smaller. So let's do that again. The x's are getting bigger, and notice they're not counting by the same amount every time. That's not important. What we just want to know is as x is getting bigger, look at what's happening here. So this would be 50, 40, 29. So as the x's are getting bigger, the y's are getting smaller. So this also would be decreasing. And let's take a look at C. Now there's an asterisk by this one, so let's take a good close look at it. This goes from 4 to 3 to 2 to 1. So the x values are in the opposite order. So let's look at this list backwards. Let's make sure the x's are going up. And if the x's are going up, what's happening to the y's? We're going from 1 to 2 to 4 to 8 to 16. So if the x's are getting bigger, the y's are getting bigger. That would be increasing. Okay? Let's look at what's happening here. Got 2, 15, 10, 5. So these are getting smaller. So let's do this. Let's go the other way. As we're going from small to big on the x's, what's happening here? 15, 12, 9, 6. So these are getting smaller. So as the x's are getting bigger, the y's are getting smaller. So that would be decreasing. Now, you could do this the other way. You could say, look, As the x's are getting smaller, the y's are getting bigger. So notice that they're doing the opposite thing. So the only one where they're doing the opposite thing is x is getting bigger, y is getting smaller, or vice versa. As the y's are getting bigger, the x's are getting smaller. So you could kind of think of it that way. I kind of like always looking at it and lining up the x's so they're getting bigger, and then I just need to figure out whether the y's are getting smaller. Okay, and then it says, state whether each of the following are linear or nonlinear, and if they're increasing or decreasing. So we want to look at these and we want to say both on these: linear, nonlinear, increasing or decreasing. So we've got a line, so that's linear, and it's going up from left to right, so that's going to be increasing. We've got a line, so that's going to be linear, and it's going down from left to right, so that's going to be decreasing. This is not a line, so this is non-linear. Now that doesn't mean we can't figure out whether or not it's increasing or decreasing. So if you notice, they're going from really big numbers to really small numbers as we go from left to right. It's going down from left to right. So this would be decreasing. This one is definitely non-linear. Okay, we don't have a line right there, so non-linear. And it's going up from left to right, so that would be increasing. And then let's take a look here. Not a line, so non-linear, and it's going down from left to right, so that would be decreasing. They're getting smaller and smaller values. Straight line here, so this is linear, and it's going up from left to right. Notice that slope that's positive. That's a big deal. That whole rate of change thing, the rate of change thing would be positive here, so that's going to be increasing. This is not a line, non-linear, but it does go up from left to right. These values are getting bigger and bigger and bigger, so that would be increasing. And then this last one here, definitely not a line, so we're non-linear, and it's kind of just doing a wavy pattern down, so this is decreasing. Okay, so we've got all those, and then I've got a couple of thought questions because you have some review assignments review problems at the end of your assignment. The first one is, how do we solve inequalities? Now I'm hoping that you've got this memorized because we've talked about this a number of times last year and this year. We solve inequalities just like we solve equations, except when we multiply or divide by a negative. Remember, if we multiply or divide by a negative, we switch the direction of the inequality. Okay, so if I had x divided by 3 is greater than 4, I can just multiply both sides by 3, and I get x is greater than 12, and I'm done right there. If I have negative 5x is less than or equal to, let's say, 20 or something like that, when I divide both sides by negative 5, I get a negative 4 here, and because I'm introducing that negative means opposite, I have to switch the direction to the opposite of what it was, and that would be the answer on that one. And then the next review question is, how do we simplify square roots? Gosh, that's going back just a little bit, so let's think about that. We simplify square roots by doing this. We factor it, and then we look for pairs of factors. So if I had something like this, if I had the square root of 18, if I wanted to simplify that, I'm going to factor it. 2 goes in there 9 times, and 9 is 3 times 3. So we've got a pair of 3's on the inside, so we can write that with 1 on the outside, and then the 2 is stuck underneath because there's nothing to pair it up with. Okay, so again, it's always a good idea to go back and review your notes every once in a while. Be prepared for a review problem on assignments, basically from now on, and you might even see one on a test. All right, good luck on this assignment.